Hello, this is Dima Seliverstov, and with Mahesh Mulye, we're going to be talking about how to leverage the out-of-the-box functionality of TrueSight Capacity Optimization to import and visualize data without having to write custom ETLs or SQLs. So the emphasis here is we want to have drag and drop in to get data into the product and drag and drop out to get data out of it. We're going to demonstrate an end-to-end use case of importing hierarchical data for example VMware using the Open CSV ETL. And we've created a simple three-tier VMware data center host virtual machine architecture. We're going to import the hierarchies, the relationship between these. Then we're going to import the actual data. Then we're going to create an analysis, and from that analysis, we're going to create a Data Mart that we will show in the TrueSight presentation console of how to create a chart and how to create a table. So the whole emphasis of this exercise is how to get to the 80% of the product functionality using 20% of the time. We have very powerful views that we create that are available out of the box, and so in many cases those views are very helpful and very useful. They'll allow you to find in a large environment the troublemaker nodes or the troublemaker entities, and it'll show you what type of trouble they're getting into. And so that's what we hope to kind of demonstrate in this particular webinar. In addition, we hope to show you how to import data into the product using a simple CSV format. So let me start. What we created initially was a simple Excel spreadsheet that we will share with you, and that allows us to generate data that shows that has typical behavior. So to start, let's talk about what we created in terms of the vCenter, data center, cluster, and host. So we have a single vCenter with a data center. We have two clusters, and then we have two hosts on each cluster. There's variable loads on each one of these virtual machines, and we're only going to pick a simple use case of CPU utilization. We have the daily batch. And the daily batch is you have the same thing happening every single day. The system is idle, it becomes busy, and then it becomes idle again. Then we have a variable batch, and the variable batch is the system becomes busy, and then it becomes idle, and it varies from day to day. Then we have the ramp function where initially the system is idle, but it builds up utilization as a function of time. And then we're going to have the final case where things are idle and basically the machine is not doing anything and it should be a candidate for decommissioning. So to give you an overview of what the waveforms look like, here we have the hourly load, which is basically nothing's happening, and then people start coming in, gets busy, and then people start leaving, and machine becomes idle again. The hourly variable case is similar. It's basically the hourly load, but some days are busier than others. You probably, you know, Sunday is not busy, but then Monday and Tuesday are busy to capture this type of behavior. The third one is we start at 10% utilization and we go to 90% utilization. And the last case is you have an idle machine. So what we do to generate this data, it's very simple, sign function and sign on top of a sign. And anytime you open this particular spreadsheet, we pick the latest time. So the data that you're porting into the environment is always fresh. And the data can be specified of a different resolution. So the process is you generate the data using these waveforms. We pick these variable entities, and we populate them to the database. So this is the actual data that we're importing, different VMs, double checking to make sure the structure that we're importing is correct. That's the data part. In addition, you need to create an object relationship database where we're going to be relating the initial structure of the vCenter, data center, cluster, hosts, and the VMs. So the relationship ETL data is here. We have to import it just once, and we're associating the data center to the clusters, the data centers relationship to the clusters, to the host, to the VMs, such that they appear in the tree, and the two entities, both the relationship and the data, will be sharing the same hierarchy. So not only will you be able to see how things fit together, you'll be able to see how they behave. So now the part of the demo, I'm going to pass control over to Mahesh Mulye, who both he and I work on Platinum Engineering. So we're developers, and we develop part of the time, and then we work with customers to get the maximum value out of the product in the easiest way possible. All right, I'm going to pass control to Mahesh.
Thank you, Dima. That was really a good introduction, and then a good way to demonstrate how the data can be generated. I just managed to create a small presentation just to explain.
Share your desktop if you can.
Yeah. Let me just share my desktop. Thank you, Dima. Can you see my desktop?
Yes, it's coming up. I'm going to make it actual size, and here we go.
All right. So basically, Dima just so there are 3 use cases we'll cover in today's webinar. The first use case is about ability to generate data for a set of systems. That Dima covered it pretty well. The next is ability to present this data for a given set of systems in a tabular format in TSPS. So for this webinar, we have taken a use case wherein for a set of systems, we will plot the CPU average, mean, and max values in a tabular format for a set of systems. And then the third is plotting the data for top 3 systems or top 5 systems in a given system. So let's look at how to achieve that. So use case 1 is already demonstrated by Dima. Use case 2 is so essentially Dima already showed how the data can be generated. The next step, logical step, is use that data and then populate that data into ETLs. So essentially we have configured 2 ETLs, one for getting the object relationships, and another is for for populating the time series data. So both of these ETLs have been configured with the appropriate CSV files that Dima just showed. So this is a file that is for the relationship, and this is the file that contains actually the time series data. So both of these ETLs have been populated, and then we have shared the entity catalog between these 2 ETLs. So that's the reason you see the same data in both the domains. So even though you see relationships over here, if I go to a specific system, you actually see the data that has been populated by a different ETL, which is this ETL, CSV columnar file parser. So you see the data over here. So we have populated CPU utilization metric from the CSV file that I just showed. So the next logical step is the first step is already complete, wherein we have populated the data in CO. The next step is creating an analysis for this set of systems. So to explain the use case at a higher level, what we are trying to do is without writing a complicated query to the database, what we will be doing is we'll be selecting a set of systems, creating an analysis out of it, and then from that analysis we'll create analysis data mart, and then from that analysis data mart we'll create a SQL data mart, and then we'll use that data mart in a TSPS view. So all this is done without writing any complicated query. So let me just go to the next step of the population, which is creating the analysis part of it. So, so I just click on the domain. I go to AdWorks. I say Add Analysis. I just clicked on next. So I'm just trying to explain the workflow. So in this case, I could select a specific entity filter. In this case, for this webinar, I have created an entity filter called Only VM that simply groups the VMs in a given domain. I just clicked on next. I just clicked on next. I could just select as system. So if you look at it, there are different templates that are available over here for for creating the analysis. For now, we have selected the CPU min max as the template, so which is over here. So what does this does is for a given set of systems in this domain, it will plot the analysis for this set of systems for the metrics that have been selected as part of this analysis. In this case, it is CPU utilization, min, max, and average. So I will not right now create it because it may take some time. So we just give some name over here, and then we get the analysis which is generated over here. So let me just cancel it right now, and then so this is the analysis that has been created from exactly the same steps that I just showed you. So as you can see over here, since I had selected all the systems as part of the analysis, and then we selected a template as CPU util, min, max, and average. For each of the systems, I can see these exact values have been plotted on a chart. So if I just look at this, it is plotting essentially CPU min value, which is very close to 0, and then max value, and then the average value. So the first part is creating the analysis, which has been done. The next part is we create analysis data mart from this analysis, and then we create a SQL data mart. So the steps for that are: we go to administration, we click on advanced reporting, we go to data marts. So this is exactly the second step, create an analysis data mart from above analysis. So I go here and then I click on add. I say data mart based on analysis and model execution. Give some name my test. I just select the analysis over here that has been created right now, which was under this domain. So I create that. I just select that analysis. If I want to materialize, I can select a data mart materialization task. I have to do the column mapping. So in this case, we got 3 values from the analysis: CPU till max, average, and min. So we can give some name to this just to map it. We could give the same name, or we can give different name, and then we just save it. All right. So since I don't want to spend time on this right now, the execution part of it, the data mart that has been created is simply this for this, using the steps that I just demonstrated, which is of type analysis and model. All right, so this is the data mart that has been created using the underlying analysis. So if we just preview it, you see the data of CPU, util, min, max, and average, which was created as part of an analysis. So this is simply analysis data mart, which is created from underlying analysis. Now the next step is you just make a note of this identifier, which is this identifier, and then from this identifier, we try to create a SQL data mart, which is simply, so I will just click on this, select data mart based on SQL. I will want to, would like to use this data mart in TrueSight console. So I select this option, I click on next. I write a query, select start from this identifier, I click on next. So I get all these columns over here, and then, I just click on next. Always see fresh data. Click on next, and then I just give some name over here like test MySQL. So this process, what this process does is, from the analysis data mart, it is creating a SQL data mart, and then you can use this data mart in TSPS. You cannot use analysis data mart in TSPS. You need to have a SQL data mart in place. So we simply created SQL data mart from the analysis data mart. And then the data mart that was created using these steps is this data mart, which is of type advanced. All right. So if I go over here, and so this is the data mart. If I just preview this, you see all the columns, and then you see these metrics, CPU util, min, max, and average over here. So we created a SQL Data Mart from the analysis Data Mart. So that was, I think, fourth or fifth step that we did over here. And then the last step is using this Data Mart in TSPS, and then plotting the data out of it. So if I go to TSPS, and then let me just try to create a fresh view. I go to administration, capacity views, and then I click on add view. Right, I will just say test webinar. Just click on next. I will select probably Data Mart Explorer. So there are different types. Data Mart Explorer is the one which allows you to, for a given set of systems, you can display the data in a tabular format or in a chart format using a Data Mart. Since right now we created a Data Mart, let's use this Data Mart and then try to create a table as well as create a chart out of it. So let's try to give it this name as CPU metrics. All right, and then let's try to plot a chart. Just let's try to plot CPU max metric over here, and then we select the Data Mart that we just created. We select the how do we identify the series. So in this case, we are identifying the series using system using entity name, right, which is the system name. And then we just picked up the metric, which is, in this case, the metric is, let's pick up the max metric, and then I just say apply. All right, and then next we can also configure a table over here. This table will, again, we have to select the Data Mart over here. I gave some title over here like CPU max, CPU min, and average. And then simply I select these columns over here. So let me first select entity name, then I select CPU max, then I select CPU min, and then I select CPU average, and then I click on apply. All right. So one more column I would need, which is the time filter that we use. So let me just add the column over here and then say timestamp. Yeah, I can just reorder the columns. Let me put this as a column number 2. Right, so it will reorder. I'll just say apply, and then I will try to save this. So as you can see over here, for a given set of systems, let's say you want to look at the same set of systems every day, and then would like to know what has been the CPU max value for the last day, or so in that case you can use this view, and then in one shot you can get data for the last whatever duration you are defined in your SQL query. So in this case we have selected 30 days as the duration in the SQL query. So you can see so the data is there right now in the query till January 29. So you can see for the last 30 days, what has been the CPU max utilization across the set of systems. Similarly, in the tabular format, you can easily take a look at, what is the for each of these VMs across hours, what is the value for this for these 3 metrics, which is CPU max, min, and average for a set of systems. So without writing a single query, just simply from the analysis Data Mart and SQL Data Mart, and using that Data Mart and TSPS, we could display the chart as well as the tabular format we could represent the data. So that was the use case that is the second use case that I wanted to talk about. And then the third use case is, let's say you have a group of systems, and then you would like to know what are the top 3 systems or top 5 systems, which are the top systems with, let's say I have hundreds of systems in my domain. I would like to know what are my top 3 systems which have the highest CPU utilization. So if I take that use case into account, we have something called as a group data explorer view. So if I go here in views, and if I click on add view, let me call it as a test group explorer. right? And then I clicked on next, and then the filter I need to select is the page type I need to select as Group Data Explorer. I click on next, and then I can say, let's say I want to look at top 3 systems. I can say top 3 VMs, right? I will say, let's say virtual system. I can select a VMware machine, virtual machine, VMware. And then I could say systems with top 3 VMs with CPU util. Right, so we'll just go here, and then I will just say CPU util here. I will add a metric for CPU utilization. All right, I'm done, and then click on apply. Click on save. And then if you look at it, so I will go to some other system, and then we'll try to see where the data exists. Let me just try to select this extractor service. Click on apply. So yeah. So as you can see, this domain has a lot of systems, but right now we have plotted only the top 3 systems over here with the top utilization in this domain. So we could select any domain as we want, and then we could plot, the systems with top utilization. So this is a domain that we just demonstrated for populating data. So if I just say apply, it will display data for top 3 VMs over here. So that is another use case that we can use to. So without writing a query, we have page types which can be leveraged to display top end systems data, or so those are the 2 use cases we covered today about without using a single query, using analysis. You can using analysis Data Mart, SQL Data Mart, and displaying data in DSPS, and then another using out of the box page type system data explorer. You can display data for top end systems. So having said that, so this is all about customizing the product. But we have a lot of out-of-the-box views which could be leveraged to get the maximum value out of the product. So you may not even need customizations for your most of the use cases. Just to demonstrate that part, I will go to, let me take an example of VMware as a platform for that matter. So if I go to vSphere views, within that, let me just see the virtual machines. So to give you an overall idea of how the whole thing works is, so this gives you a different perspectives in terms of your environment for the VMware virtual machines. So if I go to, for example, if I go to ideal VMs, so those are the VMs wherein the CPU util will be probably less than 5% or less than 3%. And then those are the VMs that you could decommission in principle, and then the save cost out of it, or those resources can be utilized for other purposes. So for example, if I go to this VM, so its CPU util must be very, very less. Yeah. So if you look at it, it's extremely, like, the value is very, very close to 0. It's just 0.28%. So those are the kind of out of the box views. Those could be leveraged. So you can even select a domain over here, and then for that domain you will get a set of systems which are idle, and then you can decommission those or take a better decision on those to save costs. So idle VMs is another use case. Another use case is over allocated VMs, where typically if you go to one of the, let's go to one of these utilizations, right? So if you look at it, so this is telling you how many VMs in my environment are over allocated. So that is second use case. Another use case which is interesting is the feature saturation use case. So this is telling you, like, so this will tell you both the things, the VMs that are saturated at the present moment, as well as the VMs that will saturate in future, so that you could take some action over here. So in this case, I don't have many VMs, that are in saturation. But in principle, you would see here, what is the days to saturation over here. So that can be used, and then the corrective action can be taken. So in this case, if you look at it, this VM, right? So it is saying bottleneck resources storage. So the file system utilization must be very heavy over here. All right, I don't see that metric here. All right. So in principle, what does this mean is, so it is telling you what is the utilization that is exceeding the threshold. So so this must be around 80. It must have crossed 80% file system utilization. That's why you see the bottleneck resource as storage over here. The other use cases are top and bottom VMs. So this is telling me with respect to my consumption, what are the top VMs in my environment. Apart from that, you also have some recommendations that you can take a look at. So this is again taking care of different, different use cases and giving you all the recommendations in one place. So as you can see over here, this will give you, recommendations about what is your forecasted saturation, or what are the over allocated VM. So as you can see over here, this VM has been underutilizing memory and storage. Reconfigure this VM to reclaim 57 GB of storage space and reduce your on-premises cost. So this is a lot of space has been allocated for storage space has been allocated. So some of this storage space can be reclaimed, and then the same can be used for other purposes rather than keeping it, unused and spending money on it. Idle VM, terminate this VMware instance to reduce your cost. So in one shot, you get all the recommendations, whether it's a future forecasted saturation, or whether the snapshots are too old, and then those can be removed, or whether the VM is over allocated or idle. So you get all the recommendations in one shot. So you can just take a look at some of these pages, in this view, and you will get a holistic insight into your environment and what are the actions that you need to take to to better utilize the resources. So that's the overall perspective that you can get leveraging some of the out of the box views. We have some other views also, wherein which gives you orientation in terms of business services and those things. Since we are near our time limit, I would keep it to this point. But our out of the box views are very powerful, and then those can be leveraged to to get the maximum business value out of the product. And then you may not need to go to the customizations, or if you leverage out of the box capabilities, your customizations might reduce dramatically. So kindly take a look at what are the out of the box capabilities. I just demonstrated some of those. So that's all we have for today's webinar. So essentially, we covered, to give a summarized proposition. So we covered getting the data, how to generate data for test purposes, populating that data, and then using that data to create custom views in TSPS without writing any single query. As well as we also looked at a couple of out-of-the-box views capabilities that can be leveraged to make sure that you don't have to have customizations or minimize your customizations. So that's the overall. That's all we covered in today's webinar. I hope it was useful to you. And then that's all from my side for this webinar. Thank you very much.
Yes, thank you very much. And if you have any questions, feel free to reach out to us. Thank you.
Thank you.